Happy noon students. So today is day 5. In this day 5 we already have studied what is the superposition of waves or interference of waves, and what we got in that one, the point at which the two waves are meeting, their amplitude there becomes a1 square plus a2 square plus 2a1 a2 cos phi. What is a1? a1 is the amplitude of wave 1, a2 amplitude of wave 2, and what is phi? Phase difference between two waves. Okay, so what will be the maximum amplitude over here? Maximum amplitude will be when cos phi is equal to 1. That means phi is 0. So what we will be getting? a1 square plus a2 square plus 2a1 a2, that is a1 plus a2 whole square, or a maximum will be a1 plus a2. A maximum is a1 plus a2. Same way, minimum amplitude, when this can be minimum? When this cos phi is minimum. Cos phi's minimum value is minus 1. So if we are keeping here minus 1, this will become a1 square plus a2 square minus 2a1 a2. That means a1 minus a2 whole square. So a minimum value will be a1 minus a2. Okay. Now since we know that intensity is directly proportional to amplitude square, so intensity at this point becomes I1 plus I2 plus 2 root over I1 I2 cos phi. What is I1? Intensity of wave 1. I2 intensity of wave 2. Again phi is the same phi, phase difference. So here maximum intensity when we are talking, so cos phi will be 1. This will become I1 plus I2 plus 2 root over I1 I2. That means I maximum we can write as root over I1 plus root over I2 whole square. And the same way I minimum, when this cos phi is minus 1, can be written as root over I1 minus root over I2 whole square. Okay. Now we are going to see if the two waves are there in string, or we should say pulses. Now what is the difference between pulse and a wave? A wave we make like this. Okay, and a pulse is just like this. Okay, if I have a string, if I am going to make a disturbance like this, one up, main position, down, like this, then it will generate one wave. Okay, but if I do like this, up and down here itself, that means I take it to upwards from mean position and down back to mean position, like this, it's a pulse. It will give generation to a pulse. If I do like this, it's a wave, but if I do like this, it's a pulse. Okay, so we are going to see, if suppose interference is there on a string between two pulses, one is this pulse and one is this pulse. If they are going like this, what will happen? Interference of wave in string. Okay, now it's happening like this. What will happen? There will be a stage when this will be here and this will be here. This is going like this and this is going like this. What is going to happen next? That is more important for us. Now see, if I make it over here. Now this point here obviously will be somewhere here. This is the topmost point, obviously will be somewhere here. Okay, let's make it first. And this point will be coming somewhere here. Okay. I'm making it like this. Same way for this one also. This point will be shifted at this point. Make it. You can see something like this will happen. Okay. This is going in this way and this is still going in this way. Now the question is, what about this? This portion. This is actually the interference zone. Here actually energy is adding up. So what will be the shape? Shape will be at this particular point. Okay, this will become straight. It will appear to you like this. Okay, it will become straight like this. So it will be like as if this is a one pulse. Then the next mode, what will happen? The next mode we can say both the strings will be like this. So how will be the shape of the string? It will appear to us like this. the energies will add up. Okay, if suppose that its amplitude is A and its amplitude is A, then here it will appear to you as 2A. The amplitudes will add up. Here also they added up. Okay, you can see that this point, whatever is the amplitude and not amplitude, the displacement at this point and its displacement at this point, both get added up and it became A. Okay, same way, wherever there is a meeting point, their displacement will be added. Let me tell you one more time. We'll take intermediate zone and I'll try to tell you. Okay, let's assume this one is here and this one is something like this. Okay, so now at this point, this amplitude and this amplitude will get added up. Okay, maybe this is something, let's say y1 and this is y2. So what will happen to the string? It will go a little up, maybe somewhere here. Okay, exactly same thing over here. Its amplitude here and its amplitude, both will get added up. So it will come over here. Okay, same way, this point and this point, this point and this point. So because of that reason, it will appear to you that it has become like this. And this thing will not appear to us at all. It will be like this. I hope you understood that. Okay, this will become one pulse. When the entire thing is inside, as I told you, this is one and this is the other one. So in this case, what will happen? Where will this pulse go? Both energies get added and it will appear to you like this. Nothing will be appearing to you like this one over here. Okay, it will appear to you like this and its amplitude will be what? 2A. Able to understand that? So you can say that this is a maximum amplitude, because in this one what has happened? A equal to A1 plus A2. That means in this particular case you can consider that the phase difference between the two pulses is 0. Okay. Now let us see another case in which the pulses are coming in opposite direction. Maybe this pulse over here. We say that it's coming like this. Okay, it means one pulse is generated like this, up, down, and from that end, another person has created a pulse from down. So it's like this. What will happen here? Now in this one, both these pulses are having phase difference of 180 degrees. So that means wherever they are coming up, what will happen? The resultant amplitude will be A1 minus A2. Let's see what's happening. This will happen. Okay. After that, what is going to happen? Next, the upper one I am making like this, and the below one, it's like this. Now you can see that where is the interference zone? This is the interference zone. Okay, now here what will happen? We have to add the amplitudes. Add means here subtraction will happen. Okay, now what is subtraction over here? How will be the shape? That all we have to check. Now let's see at this point. This point, its amplitude, whatever the displacement is, plus the displacement here is 0. So there is no change in the shape of the wave over here at this point. But check here. Now see, is this more displacement or this more displacement? This is more. Okay, so when you are doing A1 minus A2, it will be in the downward direction only. Maybe somewhere here it will come. Okay, the next, at some other point, when you check this point, here amplitude displacement of this is more and here it is 0. So how will be the shape? This shape will not be visible. This shape will not be visible to us. Then how will be the shape visible to us? It will be something like this. Are you able to understand? This is the shape will be visible to us. Okay? This is because of the interference zone. Because of the interference zone, the shape of the pulse has changed. Next step, what will happen? In the next step, both will be 1 over the other. Something like this will happen. Then, in this case, what is going to happen? I should make it in dotted because this will not be the shape of the pulse. What will be the shape of the pulse in this case? Now you see that this is minus a, this is also plus a. If you add them, what will come? 0. This is plus y1, this is minus y1, add them 0. Here plus y1, here minus y1, add them gets 0. So in this particular case, when both the pulses are 1 over the other, the shape of the string will be like this. Okay, no pulse will be visible. After this, what will happen? After this zone, what is going to happen? This pulse will go as it is, this pulse will go as it is. That means this pulse will continue to move, this pulse will continue to move. Only the change happens when there is interference happening, otherwise there is no change in the pulses. They will go as if nothing has happened. In the previous case also, what we were studying like this, when they met, there was change in the shape of the pulse. But once they cross each other, then what happens? Both will continue to move in their respective directions. Okay, so wherever they are meeting, there only the change happens. Okay, so in this particular case, there is a question. At the interference zone, when the string becomes straight, what happened to the energy? Is energy destroyed fully? And if it is not, then which form this energy is? Okay, now in this form, if I say that if the string is like this and this is this interference zone, okay, now all the particles here are in their mean position, and if they are at mean position, they must have kinetic energy. Okay, and in this position, check it over here. Is there any change in length of the string? Is string has increased its length or decreased its length? Answer is no. It's as if nothing has happened in the string. So potential energy in this position is 0 because there is no stretch in the string. But there is kinetic energy. Here all the particles have kinetic energy. Okay, so the energy in this particular region is having only one form, that is kinetic energy form. So remember that whenever we are talking about waves in string and interference in waves in string, what we have to do? If they are coming from the opposite sides but both are above, then the angle between the two we have to take 0 and the resultant amplitude will be A1 plus A2. If they are coming, one is coming from down and one is coming from top, their phase difference is 180 degree. In that one we have to subtract to get the amplitude, and accordingly we will be finding out what will be the shape of the string. Okay, let us see a few more. If suppose we take the pulses in different way, let's assume that one is a rectangular pulse, another one is a triangular pulse, something like this. Okay, both are moving in this way. What will happen the next instant? Something like this. After this, what will happen? After this will move ahead and this will also move ahead. So let's make it. I'm making it like this, and this, because their phase difference is 0, I am saying its amplitude and its amplitude has to be added. Now suppose this one is like this. If I say this is A, this is B, this is C. So A reached over here. Okay, now where is this AC then? Where is this AC? So C will be somewhere here actually, if I make it somewhere like this. Okay, so here its displacement is 0, its displacement is A. So that means this, the resultant will be here. Okay, let's see this point. At this point, this wireframe's amplitude or displacement is this, and triangle's displacement is also this. So it will be added what? It will go like this, and then you can join it. So this is how the pulse will look. Okay, this is how the pulse will look to us. Is that clear? After this instant, what will happen? If suppose the next instant is something like this, the rectangle, and this A point is somewhere here, and this is C and this is B. Now how it will appear? Again, this triangular pulse displacement here is 0, rectangular pulse amplitude is this A. So resultant will be A only, so no problem. But at this point, displacement of rectangular pulse is A and triangular pulse also is A. So this point will shoot up at this point. Then so this will be visible to us. Is that clear? This type of pulse will be visible to us. And after that, what will happen? Both will go into their own way. What is their own way? Own way is like this. So again, rectangle. This is B. And this is C. So where is interference zone? This here. Okay. At this particular point, displacement of rectangle and displacement of triangle, both are A. So this point here will be visible to you like this. And B will be visible to you like this. This is the pulse. And after some time, again, triangle goes into its own way and rectangle goes into its own way. I hope it's clear to you. Always remember, either it is A1 plus A2 when they are above the string, when one is below and other one is at the top, then A1 minus A2 we have to do. We have to see every point, add the amplitudes or rather the displacements of those particular waves or pulses and make the shape. Okay? That's how interference of waves in string is found. Okay, is that clear to you all? So that's all for interference today.